Hello, this video is for IXL activity 8.X.2 titled Graph Inequalities on Number Lines. And the 3-character code for this activity is 7 Lima Foxtrot. So the question is, graph this inequality. X is greater than 2. And it says to draw an array, plot an endpoint, and select an arrow. Select an endpoint to change it from close to open, and select the middle of the array to delete it. So that's instructions, obviously, for whenever you're doing this digitally, and it's kind of intuitive. You'll realize how it works, but we'll talk about that whenever we do this and whenever we do this first answer. Let's first talk about inequalities. Inequalities are a little bit different than equations or equalities, where things are equal. Here we're talking about where something's greater than or less than something else, or something's greater than or equal to or less than or equal to something else. And here we have x is greater than 2. Remember, this sign is read as is greater than. If you think back to grade school, the alligator's eating the bigger one. So wherever the open side is, that's the greater side, right? So x is greater than 2. Now, whenever we did this before in another activity, we were just graphing numbers on a number line. Remember that one, horizontal and vertical number lines, graphing numbers? Well, in this one here, we're going to have something a little different. In the equalities, we just had a dot on the number line. Here we're going to end up with a ray. A ray has an endpoint, and then it goes on forever in another direction. So it's going to either be going to the right, to all the greater numbers, or to the left, to all the lesser numbers. So we have to consider open dot or closed dot. And whenever we talk about open dot or closed dot, we're talking about whether or not it's greater than, less than, or greater than or equal to, or less than or equal to. Remember, a little brief review here. I'll do that over here to the side. Here we're starting with greater than, so we'll go ahead and use this. If it's greater than, or if it's less than, then in this case, we want an open dot. Right? We're going to make an open dot on the number line at that point. In this case, it's going to be 2. And this is because 2 is not included. The number is greater than 2. It can't be equal to 2. And so that brings us to the point of if it's greater than or equal to, or if it's less than or equal to. In this case, for these two, we're going to have a closed dot. And that is because, I finished spelling the word dot there before I multitask my brain too much. The reason for that is because it could include that point, because we're saying that it's either greater than or equal to, or less than or equal to. So the equal to concept says, yes, that point that we are graphing could indeed be a solution to it. So we have to include it. Open dots, that point's not included. Closed dot, that point is included. So let's go ahead and graph this first inequality. So 2 is the point in question. So we need to find 2 on the number line. And here's 2 right here. So let's go ahead and on IXL, you click it, and then it would give you an open dot. And notice we want all the numbers greater than 2. So that's all the numbers to the right of 2. So I go down here, and if you click down here at the end of the arrow, IXL will go ahead and put a line in the rest of the way there. And it'll fill that in just like that. So click once at the point, then click on the end, whichever end you want the arrow to go to, or to be exact, the ray for all you geometry people out there. And then it'll fill in your answer. So this is the correct answer. And notice that our variable is on the left. And if you watch the lesson, we talked about this. As long as our variable's on the left and not the right, because we could write this as 2 is less than x, right? That would still be 2. 2 is less than all these x's, right? So 6 is a possibility, 10, 8, all these numbers. 2 is less than all those numbers. But if we write it in such a way that our variable is on the left over here, then we can use the sign as kind of a cheat to tell us which way the arrow needs to go on our number line whenever we graph it. So always keeping it on the left really helps you out of knowing which way to go. So let's look at the next problem. Here we have x is greater than or equal to negative 2. Remember, this sign is read as greater than. And so let's find the negative 2. I'm going to click it once. And notice that it has the equality concept there. It's greater than or equal to. So if I click it a second time, IXL is going to put a solid dot in there. So click once for open, click it a second time for a solid dot, and then which way does my arrow need to go? Well, all the numbers that are greater than -2 are to the right of -2. So I'm going to click down here at the end, and whenever you do that, it's going to go ahead, you click down here at the end, it'll put in a line there the rest of the way, and then our arrow's pointed to the right. And again, notice that the inequality symbol is pointed to the right. It looks like an arrow point to the right, and our line on our graph is pointing to the right as well. But we have to make sure that that variable is on the left whenever we do that. If this were flipped around the other way, it might mislead us. On the next one, let's go ahead, and you'll see how this actually starts to go pretty quick, right? So let's find 6. There's 6. Click it once. Open dot. It has the equality portion. Click it a second time. Close dot. And then which way does the arrow need to go? Well, it's pointing left. So if I click down here on the left and fill that in there, I should be good to go. And if we check that out and see, let's pick a number, like 2, right? 2 less than equal to 6. Is this a true statement? Indeed it is. 2 is less than 6, so my arrow must have gone the correct direction. Remember, you can always check your answer by picking any number that's in that part that you're representing as a solution to the inequality. On the next one here, x is greater than or equal to 0. So let's find 0. Click it once. Open dot. It does have the equality concept, so click it a second time. Close dot. We want to include that 0 in there. And then the arrow's pointing to the left, so or to the right. If I click to the right down here on the end, it's going to put in this arrow for me. And I could always check that and make sure. Put in 20. 20, I'm going to pick 20. 20 is greater than or equal to 0. Is this true? Indeed it is. I must have my arrow in the correct direction. Looking for -40. And notice x is less than -40, so no equal portion right here, right? So we want an open dot. We do not want to include that value of -40. The arrow's pointing to the left. Let's go ahead and click to the left here, and IXL would put that arrow in there for us. And then we could always check it out and see, well, think of a number down here that's down here, like -100 is way down here someplace, right? So plug that in. -100 is less than -40. Is this true? Indeed it is, so my arrow is going in the correct direction. Next one, find -500. Right there it is. Close dot or open dot. Hopefully you're saying close dot because it has the equality concept with it. It's greater than or equal to, so we need to have a solid dot because -500 is also a solution. And the arrow's pointing to the right, so I'm going to click down here to the right, fill that line in there, and I can always check my answer. What's way down here? 0, right? 0 someplace down here. 0 greater than or equal to -500. Well, -500 is like, which would you rather have? Would you rather have $0 or owe someone $500? So it's better to have $0 than to owe -500. So I don't know if that's a good example or not. Skip it. Ignore me. At any rate, 0 is indeed greater than -500. All the negative numbers are to the left. And here we're looking for 672. 672 is right here. So click it once. Open dot. Should we leave it an open dot? Indeed we should. No equality concept there, just greater than. And since it's greater than, that's all the numbers to the right. So I'm going to click down here, and it's going to fill in that line for me. I could always check that out and see, is that true? And pick a number like 676. 676. Is this greater than 672? Yes, it is. Correct answer. And the final one here, looking for 310. There it is right there. Click it once for open dot. Should we click it a second time for close dot? I hope you're saying yes, because it does have the equality concept. So we're going to click that there for close dot, and the arrow's pointing to the right. Remember this trick of using the arrow here, the inequality symbol arrow looking thing. The trick to using that is a clue of which way your line is going to go. Involves having the variable on the left. So if your variable is not on the left, if you had 310 over here, x over here, and because this would be the same statement, this statement and this statement, those two inequalities are the same thing. But if you tried to do it this way, that arrow would tell you, oh, go to the left, and you actually need to go to the right. So This only works if it is with the variable on the left. It does not work if the variable is on the right. All right. So those are all of my examples for IXL 8.X.2 graph inequalities on a number line. And good luck with your activity.